Hello dear students, welcome back to my channel. Honors Academy. Here, Honors Academy, the ultimate destination for comprehensive physics lessons, specially tailored for 11, 12, JEE, NEET and CET aspirants. On this channel, you will discover engaging video lectures explaining complex physics concepts, detailed solution to JEE and NEET and CET physics problems, and study tips and strategies for SEU exams. So come, join me in this journey to master physics and achieve your dreams. So this is a MCQ series of MEEC, magnetic effect of electric current. Children find this chapter and electromagnetism and 2-3 other chapters very difficult. So now I thought that I'll start the MCQ series for this chapter itself, so that it becomes easier for you people. It could help you. So, moving on. So this is my fourth video on this MCQ. So our question says that an arc of a circle of radius r subtended an angle pi by 2 at the center. See, arc of the circle, everybody knows arc of the circle means what? In 10th itself, in maths we have studied arcs and all. So you know, arc in simple words, टूटी हुई चूड़ी का टुकड़ा. This is an arc. So what it says that this that is the arc of a circle of radius r. Subtend radius r means this could be the center of XYZ circle. This could be the center and this is the radius. So what it is saying, it subtends the angle pi by 2 at the center. So here somewhere it is, if this is point O, and this is the arc we are speaking about. Okay, what we are talking here. So it is subtending an angle of pi by 2. It carries a current I in the magnetic field at the center will be. So यहाँ पे हमें B at this point हमें निकालना है. We have to find B means magnetic current at this point. Okay. And the current is flowing in this direction. This is point A and this is point B. Okay, this is for our ease. So now getting on to solution. In order to, now what we need to calculate is magnetic field at this point. At this point we need to calculate magnetic field. This is being asked. So in order to calculate the magnetic field for this particular shape, we need to apply the concept of Biot-Savart's law. You know Biot-Savart's law, everybody should be well versed till now. See, Biot-Savart's law is an equation describing the magnetic field generated by a constant electric current. See, in physics, whenever anything is defined or anything is said, it's each and every word of the sentence, it has its own importance. So constant, here what it is saying, constant electric current. This is also very important. Means the current which is flowing, it should be constant, it should not vary. कि 2 एम्पियर जा रहा है, फिर 4 एम्पियर जा रहा है, फिर वापस 2 एम्पियर, 4 एम्पियर, 8 एम्पियर. इट शुड नॉट गो दैट वे. 2 जा रहा है तो 2 ही जाए, 4 जा रहा है तो 4 एम्पियर ही जाए. Sorry. Now it this relates the Biot-Savart's law, it relates the magnetic field to the magnitude, direction, length and proximity of the electric current. And this law is named after Jean-Baptiste Biot and Felix Savart, who discovered this relationship in 1820. You should be knowing this thing, but I thought कि चलो थोड़ा एक्स्ट्रा इन्फॉर्मेशन भी होना चाहिए जो हम पीछे छोड़ दिए हैं. Actually we have all been dealt with all these things. So now we'll apply Biot-Savart's law. Okay, Biot-Savart law. So what it states, Biot-Savart's law, it states that B means magnetic field in such condition is, see, in previous videos we have seen magnetic field inside the solenoid, magnetic field around the straight current carrying conductors. So they have given us so many situations in which कि अगर ऐसे सिचुएशन है यू हैव टू यूज़ दिस फार्मूला, अगर ऐसे सिचुएशन है यू हैव टू यूज़ दैट फार्मूला. हमें सिर्फ उसको याद करके अप्लाई करना है. दे हैव फाउंडेड, दे हैव डन द वेरी गुड जॉब. अपने लिए बहुत आसानियाँ करके गए हैं. दे हैव मेड एवरीथिंग ईजी फॉर अस. सो वी जस्ट हैव टू नाउ फॉर इन दिस कंडीशन what we have to apply, it is mu naught upon 4 pi into I dl upon r square. See, in the previous one for straight current carrying conductor it was different. B inside the solenoid it was the different mu naught ni it was, and so on. So there are so many equations they have given, formulas, sorry, not equations, formulas. And see, this is the scalar form. Okay, so here dl means, now this is the new word. What does dl means? Dl means, I think you people get that we are taking this small thing out of the whole circle of the big radius. We are taking only a small portion of it. So whenever we take small portion of anything, we use the letter D, dl. dl, D means small, L, small L. We are taking the smallest thing. Okay, just to study. And here, what is it? It is this small dl is arc AB. We have given it the name AB. So here dl is our arc AB. So now arc subtended is equal to radius into angle theta. Okay, so arc AB is equal to radius is given r, and the angle theta is pi by 2. So now putting values in these things, what we get, B is equal to mu naught upon 4 pi into I into R into pi by 2 the whole upon R square. This is a formula. We have to just put the values in it. So therefore B is equal to mu naught upon 4 pi. Here see, now what we'll get, all these things will get cancelled. See, we'll directly do this thing. This pi and this pi gets cancelled. This R and this one R gets cancelled. So what we get here is B is equal to mu naught I multiplying these the whole upon 4 2s are 8 R. So where is this? Where will we find this? This is in option B. Hence option B. Okay, so we will see more such MCQs. Stay tuned. So now our next question, it says magnetic field intensity at the center of a coil of 50 turns whose radius is 0.5 meter and carrying a current of 2 ampere is, and our options are 0.5 into 10 raised to minus 5 Tesla, 1.25 into 10 raised to minus 4 Tesla. Option C says 3 into 10 raised to minus 3 Tesla, and option D says 4 into 10 raised to minus 5 Tesla. So now moving on to the solution. See, our solution says we have to find the intensity of the magnetic field intensity at the center of the coil is given, and we have to so we have to find B at the center of the coil, isn't it? So what is the formula for B at the center of the coil? It says, we have done these things in my previous videos also. Mu naught upon 4 pi into 2 pi Ni. N means number of turns, I stands for current, and R stands for radius. Everything is very well defined. Okay, and just by applying means putting out in the values B center, now see B center, what we get is equal to mu naught, because this 2 ones are 2 and 2 twos are 4. These 2 gets cancelled. Here we'll first write down the given things. Once N is 50 turns, okay, R is radius of 0.5 meters, and I is equal to 2 ampere current. Okay, so now what we are left with, mu into Ni the whole upon 2R, isn't it? Now putting the values here, what we get, equal to 4 pi into 10 raised to minus 7 into 50, which is N, into I, which is 2, the whole upon 2, and the R is 0.5. Okay, putting all these values in the formula. Again, what we get B is equal to see here, calculating these 2 into 0.5, it becomes 1. So we get 4 pi into 10 raised to minus 7 into 100, the whole upon 1. Okay, which becomes to 4 pi into 10 raised to minus 5. Now you'll ask this thing, because cancelling these two 0 means 100 के जो 2 zeros है वो निकाल दिए, तो this becomes 10 raised to minus 5. Okay, this is simple. I think everybody knows this. And on multiplying this 4 into 3.14, 10 raised to minus 5. But here there is no option of 12.56, but there is one option of 1.2 into 10 raised to 4. So what we can do is we can convert this thing, we can shift one decimal here, and then we can get into 10 raised to minus 4. See children, these small shortcuts and smart work, you have to know this thing. You should be very familiar with all these things. You should be very easy going with such substitutions. Okay, hence option B. Okay, so moving on forward, stay tuned. So now our next question in MCQ series of MEEC, it says that a current I flows along the length of an infinitely long, straight and thin walled pipe. Then the magnetic field at all points inside the pipe is the same but not zero. These are the options, and option B says the magnetic field at a point inside the pipe is zero, and option C says that the magnetic field is zero only on the axis of the pipe, and option D says the magnetic field is different at different points inside the pipe. Now see, we will see what actually it says and what it means, and we will find out. It is a very easy and what we say, halwa question. See, this is a thin walled pipe. Okay, suppose this is a thin walled pipe, means it is a cylinder. What is it? It is a cylinder. We consider it as cylinder. So in case of hollow pipe and pipe of the magnetic field with magnetic field inside the pipe are always zero at each and every point. Whenever this question comes, it becomes very easy. See, there is if we have gone through our topics very well, and if our concepts are really clear, you will automatically come to know this thing without even going through the options. You will come to know कि अच्छा ये ऐसे है. Yeah, we know in case of hollow pipe, the magnetic field inside the pipe, it is always zero at each and every point. Hence the option is B, that the magnetic field at a point inside the pipe is zero. Okay, so moving forward for another MCQ. See, we are going from easy to hard. We have we'll solve more than 60 MCQs based on this topic itself. So stay tuned till the end of this these MCQ series. You'll become, inshallah, you'll definitely become pro. Okay. See, moving forward with the next MCQ. Our next MCQ says a wire PQR is best shown in this figure, and is bent in the region of uniform magnetic field. Means here there is a uniform magnetic field. This indicates the magnetic field. So the length of PQ and QR is equal to length L. A current 1 ampere flows here. 1 ampere current is flowing. Okay, through the wire as shown. The magnitude of the force on PQ and QR will be, option says A, BIL 0, 2 BIL 0, 0 BIL and 0 0. Here see, both PQ and QR have the same length, isn't it? This is what it says. This line says that PQ and QR, they have both same length. Here we need to evaluate the force on PQ and QR. इन पर PQ और QR लेंथ तो सेम है, पर इन पे क्या फोर्स लग रहा है हमें वो ढूंढना है. तो हम इस तरह से ढूंढेंगे. force on PQ, okay, and here force on QR. Now see, PQ is horizontal, it is going in this direction, this is P and this is Q. इसे समझो ये उठा के मैंने यहाँ रख दिया, ओके, एंड हमारी मैग्नेटिक फील्ड जो है ये इसका डायरेक्शन भी देखिए क्या है, इट इज़ इन दिस वे B, ओके, एंड द लेंथ इज द सेम, दिस इज माई करंट I1 एम्पियर फील्ड. यहाँ पर जो देखने की बात ये है कि हमारा जो मैग्नेटिक फील्ड और मीन्स B and I and length all are in the same direction, that is see, length and magnetic field, that is B, both are parallel to each other. In other words, we will say parallel to each other, isn't it? So in this condition, the angle between L and B is 0, okay, the angle between length and B is 0 in this condition because there is no angle. See, they दो parallel lines के बीच में कोई angle बनता ही नहीं, isn't it? So here angle theta is equal to 0 degree, okay. तो इसके लिए इक्वेशन हमारा क्या बन जाएगा, F इज इक्वल टू BIL साइन थीटा. ये हमारा जो है वो फॉर्मूला है जो हम लगा के हम निकालने वाले थे. सो यर BIL साइन थीटा है ही नहीं, साइन थीटा इज 0, सो वी विल राइट 0. सो यर फोर्स इज इक्वल टू 0. यहाँ पे हमें ये मिला. नाउ विल सी फोर्स ऑन QR. व्हाट इज QR? अब हमारा यहाँ पे see, we are talking now about this line. ये इस तरह जा रहा है, this is R and this is Q. ऐसे समझो हमने ये उठा के यहाँ रख दिया. And the line again, the B line is going this way. The length is also going this way. So here the direction of B and L is different. B और L की जो है वो डायरेक्शन डिफरेंट है एंड इट इज़ परपेंडिकुलर नॉट पैरेलल. देखिए ये परपेंडिकुलर हो रहा है ना, ये लेंथ है हमारी, ये लेंथ है, इसको अगर हमने टच कर दिया तो इट इज़ मेकिंग एन एंगल, इजंट इट? तो मतलब वो पैरेलल नहीं है, सो देयरफॉर इट इज़ फॉर्मिंग एन 90 डिग्री एंगल. तो यहाँ पर हमारा फॉर्मूला क्या हो जाएगा, F BIL साइन थीटा. तो F इज इक्वल टू BIL साइन थीटा 90 डिग्री है एंड 90 डिग्री मीन्स 1, इजंट इट? सो हमारा ऑप्शन क्या होगा, फर्स्ट 0, फर्स्ट आया हमारा 0 और फिर आया BIL, हैंस ऑप्शन C. Okay guys, so here we end our MCQ. We will see more MCQs in our next video, so stay tuned. We are going every time I am repeating the same thing, that we are going from in the ascending order from the easy MCQs to the toughest ones, so that आपको पता भी नहीं चलेगा ट्रांसफॉर्मेशन के आप इतना टफ वाला कैसे करने लगे इतने इजी से. बिकॉज व्हेन यू डू दिस थिंग, सी आई एम शोइंग यू वंस, बट you have to practice it after watching the video. You have to practice it on your own also. Do the same thing, go on repeating. Once you see in the video, afterwards you do it without looking into the video. And if you are able to do this thing, if you find such MCQs easy, then we are proceeding forward for more harder MCQs till the end. We'll encounter more than 60 MCQs. So stay tuned and please comment comment in the comment section, because that is the only way we can get connected, and I'll come to know what else you need, where means which type of which chapter you want, or are you happy or satisfied, do you understand my language, or do you get along well with my way of teaching. So that is the only platform. By commenting we can get connected. So I'll be waiting for your comments, and do please like, share, comment and subscribe my channel. Thank you children for watching me.